So here I have 2.8 kilograms dry weight of Jason's ore from his mine ground up. You can see my previous video if you want to watch that process, the grinding and the splitting of the material. This is the free mill stuff. Got quite a lot of contamination with black sand and so forth, but that's not going to matter because I have a method using aqua regia and cupellation where I can get relatively pure gold to weigh. I moved the panning tailings from this big tub back into here, and now I'm going to transfer that into there, and I'm going to roast these sulfides for an hour or two. Here's the roasted sulfides. They look different for sure, quite a bit different. There's the sulfides roasted. Hopefully they're no longer sulfides. So the next step is to clean this up with some hydrochloric. So I've got a little water in there. That's about 70 milliliters of hydrochloric acid. There's the sulfides reacting, and it smells like sulfur. Okay, so after 3 flushes of hydrochloric treatment, it's now a light brown color. And I'm going to rinse that with tap water and then deionized water. So I just took a look. There's quite a bit of gold I've liberated from the sulfides. And now I'm going to treat this with aqua regia to collect it all up together eventually. Hydrochloric acid. Here's the free mill gold that I panned out. That was actually yesterday. So I'm going to digest that also in aqua regia. Here's the tailings from the first run, and I've switched machines for a purpose because, you know, in some sense, if you don't catch the fine gold in the first run and you run it again on the same machine, unless you dramatically change the settings and so forth, I'm not sure you'd get much more of the fine gold. So I know this machine will separate 300 mesh or 50 micron gold pretty well. Not, perfectly, but it does a pretty good job if I get it set up correctly. So I use this to set up the table. With this table, I run it flat, in other words, 0 tilt in this direction. And the tip, I'm running at 3.6 degrees. So there's the concentrated tailings, and just going to roast it. Here's the roasted ore, about an hour. I stirred it a couple of times. It's completely different than when it went in. All right, that's what I've got. Yeah, same process. Going to clean with HCl, probably 3 times, and then dissolve in aqua regia. After dissolving all of the gold in aqua regia, here are the 3 samples that we have. The first one is from the free gold that I got from panning out the original concentrates. The second one is the panning tailings, which had a lot of sulfides. Roasted, cleaned it up in HCl, and then dissolved it in aqua regia. And then sample number 3 is I went back to the shaker table tailings and I ran them through the table again. I roasted, cleaned, and dissolved that in aqua regia. So we have 3 different samples to take a look at and measure the gold concentration. So the next step is I'm going to add urea to each one of these to kill any residual nitric acid that might be in there. This is a saturated solution of urea, and at room temperature it contains 1.2 grams per milliliter. That's enough to consume or to react with the nitric acid of equal volume of 67% nitric. So if I added 20 drops here, I add 20 drops of urea of the saturated solution, and then I know I've killed the nitric. So I'm going to go through and do that for each one of these. So now that the nitric is consumed, I'm going to dilute these each with some water. So the process of adding the urea and dilution will actually bring the silver out of the solution as silver chloride. Silver chloride has very little solubility, very low solubility in water at room temperature. So that will essentially remove almost all of the silver when I filter it. So you can see I've got a lot of colloidal silver. I got silver chloride floating around in there now, which is exactly what I want, because I don't want to, in the next step, have any silver in this sample at all, because I only want to measure the gold content. Okay, I've got some cotton in the bottom of this funnel, and we'll just pour that in there. And then I'll rinse this out and a little bit and do it again. And then when that finishes filtering, I'll rinse the cotton out so I don't lose any gold. And then I'll do the same with the rest of these, and we'll take a look. This one is very clear. This one is extremely clear. This one is slightly cloudy. I'm going to run that back through the filtration process one time and see if I can clean it up a little bit more. Okay, now they're quite clear, and I'm happy with that. So I'm going to transfer these into some small beakers, because now we're going to drop the gold. I've weighed out 100 milligrams of stannous chloride in each one of these little beakers, and now we're going to add that to here. Oh, there's a lot of gold in there, huh? So that's the gold we got out of the, that's the free milling gold that we panned out. These were the tailings from the panning, and that was full of sulfides, and I roasted it. Let's see if there's any gold in there. Well, there certainly is. Let's stir that up. And this was the shaker table tailings, which I then ran through another shaker table to see how much more gold we could extract from that. And let's see what we got here. Okay, so really not so dark, huh? Not very much gold left in the shaker table tailings. Okay, it's been about an hour. So the gold should have clumped as much as it will. We'll see. I've got a fresh filter, cotton filter in there. And I'm going to pour this into here. And the gold will stick to the cotton, most of it anyway. So that was the free gold. Here's the panning tailings with all the sulfides. Same idea. The more gold we have stuck in the filter, the easier it is for the gold to stick to the filter. So I'll run this back through there several times to make sure we've got all the gold out of here. And here's number 3, and the concentration of gold is pretty low, so it's not clumping as well, but it will eventually. I may have to leave this overnight even. I'll put that into here. And you can see that it's almost run clear. There's a little bit of gold, not very much. So I'm going to run this back through there, and we'll catch almost all of the rest of it. So we'll let that run. Now this one, let's take a look at what we've got here. So you can see that basically all of the gold is gone. We only have a green liquid left. Nonetheless, I'll run this back through just in case we've missed some tiny amount. So here's a couple of cupels. I've used them once. They're perfectly clean, so there's no chance of contamination. And I can use these about 4 or 5 times actually in this process. So I'm going to remove the cotton with that gold and put it in the cupel. There's a little bit of gold left in there. You can see it in the funnel, and what I'm going to do is to swab that out. So I use another piece of cotton and just swab that all up. It's clean. here's the panning tailings. And that funnel came perfectly clean, so I don't have to worry about that. Now that I've freed up a funnel, I can deal with number 3 here. And this is what we got after running that through twice. So I don't know if you can tell so easily, but it's a perfectly clear liquid. There's no gold left in there. Now, I'll pull that out. And that goes in our third cupel. The free gold, panning tailings, and shaker table tailings. Okay, here's something important. This is called assayer's lead or test lead at Legend. And you can buy 5 pounds of it. It's, I don't know, 40 bucks or something like that. And it's guaranteed to be free of impurities, especially silver. So I bought some of this for this purpose, but I checked it by just cupelling a piece of it alone, like 30 grams, and there's a hell of a lot of silver in it. I mean, enough to kind of wreck the experimental accuracy here. So I can't use that, so I bought the assayer's lead. And I only need, in each one of these cupels, I need 6 grams, I found, to do a great job. Number 2 and sample number 3. All right, there are the, they're hot. There's the 3 samples, 1, 2, and 3. Here's 6 grams of lead. And that'll suck up all the gold inside of there. And there won't be any gold left in the cupel. It'll all go into, it'll amalgamate with the lead. The lead will oxidize, and the cupel will absorb the lead oxide, leaving just the gold. Number 1, number 2, and number 3. The free mill gold, the panning tailings, and the shaker table tailings. We found in the free mill gold about 13 milligrams. In the panning tailings, from panning out, the concentrates from the shaker table, first run, I got 3.2 milligrams, or about 25% of the gold was left in the panning tailings that I could recover. I then ran the shaker table tailings back through the process again, and I recovered another roughly 1 milligram. So, less than 10% was left on the shaker table, in the shaker table tailings. The total gold that I recovered through this whole process was about 17 milligrams. We started with 2.8 kilograms. So we calculate the specific concentration of gold in the ore as, say, 17 milligrams out of 2.8 kilograms. There's 1,000 kilograms per metric ton. There's 1 gram per 1,000 milligrams. So you see the kilograms cancel, the milligrams cancel, and we're left with grams per metric ton. 6 grams per metric ton. Another way of saying that is 6 parts per million. And this is pure gold. There's almost no silver in this gold due to the process of dropping the silver and then filtering it out. And I've checked this several times with other methods, and it's at least 95% pure gold. If you recall from the last video, I got 11.5 parts per million through the fire assay process, but that included the silver. So I'm sure some of that is silver. So these results don't vary too much from the fire assay. The fire assay catches basically everything. This catches some percentage of the gold that's extractable by my method. So this number is very interesting to decide whether the ore is economically feasible or not. Anyway, thanks so much for watching.